These are the frequently asked questions for section 5.7 day 1 in Algebra 2. I'm going to start with the expansion of x minus y to the third. And as we look at this as an a plus b to the n problem, we realize a will be x and b will be y. And we start with our a's, high to low. So x to the third, x squared, x to the first, x to the 0. And then we take our b's low to high, y to the 0, y to the first, y to the second, y to the third. And then we need to go to Pascal's triangle so that we get the c's. Remember, we have a's, b's, and the c's come from a field of math called combinatorics. And since we're looking for the third row, since we have third power, this is row 0, row 1, row 2, and row 3. We need the 1, 3, 3, 1. And then we have to put a sign in between each one of these terms. And since this is subtraction, it's going to oscillate positive, negative, positive, negative. And then we go ahead and simplify. We don't need the plus, we don't need the 1, we don't need the y to the 0 because that's 1. We need the x to the third. And then we don't need this little 1 for the power in the second term, so minus 3x squared y plus. We don't need this little 1 in the third term, so 3xy squared minus. We don't need this 1, we don't need the x to the 0 is what I meant to cross out there. We don't need that. We just need the y to the third. And so this one is complete. And you can see the patterns again of the x's, the a term high to low, the b term, the y's low to high. And then you can actually really see the 1, 3, 3, 1 in this pattern. Next one is number 26. We are supposed to find the fourth term of x plus 2 to the fifth. All right. So I think about my a's, which in this case are x, and I realize if they want the fourth term, I have to start counting down from 5. So it's 5, 4, 3, 2. So I'm going to use the second power for my x in order to make sure that I have the fourth term. And then my b value up here is a 2. Now, this power that I have for my a and the power that I have for my b have to add up to the highest power available, which is a 5. So if I have a 2 for my a term, I'm going to need a 3 for my b term. And then I'm going to need to go to Pascal's triangle again. And with this one, we would need to go to row 5. So I'm going to back up and we'll go to row 5 on this. By again, just starting with 1s, and then to get any number, you add the 2 numbers above. So this is row 4, and this is row 5. So for row 5, we have 1, 5, 10, 10, 5, 1. So it would be 1, 5, 10, 10 for that term. So we're going to put a 10 in the front. And this one had plus, so I'm not worried at all about whether or not this should be positive or negative. So this will be whatever we get when we multiply these numbers together with an x squared behind it. Well, we have 10 times 2 to the third, which is 10 times 8, which is 80 x squared. So that would be the fourth term for number 26. Then for number 29, I see that my a is really an a this time, but my b is 5b squared. And this is all to the fourth power. And they want the fifth term. So I think about my a's and how my a's would start at 4. So 4, 3, 2, 1, 0. They want the a to the 0 term. So if I have a to the 0, I'm going to need b to be to the fourth power, because those 2 powers have to add up to 4. And then what I need to do is go to Pascal's triangle, and I need to go to row 4, and I need to look for the fifth term. Well, the fifth term in that fourth row is going to be a 1. So we have 1 times a to the 0, well, a to the 0 is just 1. And then we have 5b squared to the fourth power. So really what we need to figure out is, what is 5b squared to the fourth power? So that will be 5 to the fourth, which is 625. And then when you have a power and you raise it to a power, you multiply those exponents. So that will be 625b to the 8th. Number 41 says we want to expand 5a plus 2b to the third power. So our a is really 5a and our b is really 2b. So we need to start with our a's from high to low, and that will be 5a to the highest power, which is a 3, 5a to the second power, 5a to the first power, and 5a to the 0 power. And then we take our b's, which in this case are 2b, and we go ahead and take those low to high. So 2b to the 0, 2b to the first, 2b to the second, 2b to the third. And then we find that third row of Pascal's triangle. And the third row of Pascal's triangle is 1, 3, 3, 1. We look at the signs and we see this is addition, so that means we'll have addition all the way through. And then we simplify. So this first term, this is a 1, so is this, because it's to the 0 power. So we really just have 5 to the third, a to the third, which is 125, a to the third, plus. And in the next term, we would have 3 times 5 squared times 2. Well, that's 3 times 25, which is 75, and 75 times 2, which is 150, a squared, b, plus. The next one, we have 3 times 5 to the first, which is 15, and then we have 2 squared, which is 4. 15 times 4 is 60, a, b squared. And then the last term, we take a look and see we have a 1, and this is another 1 because it's to the 0 power, and then we have 2b to the third. So that will become 2 to the third, which is 8, b to the third. And that's our answer for number 41.